Hello once again. So this is another video session about basic computer programming, and this time we'll talk about data types and variables as part of our um, course in writing basic computer programs using Java programming language. And in this particular video session, you will be able to identify what a data type is and also declare a variable. So variables and data types are intertwined, they are partners, and they're very essential and very important in writing computer programs because through data types and variables, we are able to store data and we are able to manipulate data, such as performing calculations. And these are fundamental in writing computer programs because essentially a computer program accepts, processes, and produces relevant data. So learning how to identify data types and how to declare variables are very important in writing computer programs. So as you can see on the screen right now, it is a flowchart, and based on our previous discussions, based on our previous videos, a flowchart will graphically show us the flow of our program. And when we write our codes, whatever programming language that we use, we base it from our algorithms. And flowcharts are expressions of algorithms. And using flowchart will essentially make writing the codes convenient on our end because flowcharts have gone into analysis already based on the scenario of the ideal program that we are writing. And so basing our coding from our algorithm will essentially make our coding experience easier because through algorithms like flowcharts, we have already analyzed the entire situation and have come up with a model or a design which enables us to conveniently write our codes by the time we are ready to code it. On the right side is a depiction of the data that are required based on the model that's shown on the screen right now. So because we were asking from the end user to enter the first number, then the first number is going to be our very first data that we will handle. The flowchart also shows us that the end user will have to enter for the second number. And so the second number will become our second data if we come to think of it. Now, on the right side, um, it's depicted that it's assumed that for the first number, let's say the end user will enter 10, and the second number, let's say the end user will also enter 10. And based on the flowchart, there is some process going on, and the process states or depicts that we have gotten the sum of the first number and the second number. And so the sum will hold another data, and so sum is going to be our third data. And as you can see on the result, because addition was performed, then the result will be 20. And so 20 is going to be our third data. So the question now is, where are we going to store those data, right? Now, in writing computer programs, it is very important that we are able to manage our data. It's also very important that we are able to store those data. Now, if you come to think of it, if we are asking for the end user to enter data, then the question should be, where are we going to store those data? So let's say, for example, you wish to withdraw some cash in a particular bank, and uh, you go to the nearest ATM and enter. the amount of money you wish to withdraw. Now, the system of that bank will have to remember how much you would like to withdraw from your account. And so essentially, if you come to think of it, the system um, needs to store or remember the amount of money, the figure of money that you wish to withdraw. And basically, what happened there was when you enter the amount of money, let's say, for example, you wish to withdraw 1,000 pesos. Now, what happened there was the amount of money was stored within the computer or within the system of the bank so that it will be able to remember or recall how much money you would like to withdraw. And so use that data depending on the amount of money that you entered in their calculation. Now, since you wish to withdraw that, then the calculation will be to deduct the amount of money you wish to withdraw from your account. And that's how data works in that particular setting, and in most cases, actually. Now, in computer programming, we need to store our data, of course, in our computer. And where do we actually store this is actually in our random access memory. And random access memory is a hardware component within our computer system, which enables us to, or enables your computer to handle or to manage data. So let's say, for example, you are entering your name, or maybe you are using your calculator. And as you can see, when you are calculating or computing for something, as you can see, your calculator can actually show you the previous calculations that you've made, or um, maybe you are using a particular system. And let's say, for example, you go to a supermarket and you bought something and you go to the cashier, and as you can see, the cashier was able to quote unquote record the item prices that you have purchased. And so these things are happening because our computer has a way to record or to remember the data that it processes. And we can achieve that through the help of our random access memory, which is shown in your screen right now. And what really happens in there is that those data that we handle are quote unquote temporarily stored in your random access memory in its spaces inside. So let's just use the analogy or term spaces so that we get away from the very technical aspects of talking about the hardware random access memory. But we can use an analogy. We can think of a random access memory as a building which contains a lot of rooms. And so we need to store a data in one of the rooms available in that building, right? So in other words, the data that we store is going to be stored in what we call variable. And variable is a memory space inside your RAM. And these memory spaces are ready to hold temporary data because we will manage those data in the future. By saying manage those data in the future, I mean using these data for calculations, right? And so here is another analogy of using data, of course. Uh, we have cabinets, and inside cabinets, we store, quote unquote, our wardrobes. So we store our shirts in a particular section of the cabinet. We store our jewelries or other stuff in a particular section of the cabinet. And we also store our jeans in another section of the cabinet. So as human beings, we recall or we remember which particular section have we stored our jewelries, which particular section have we stored our shirts, our polos, which particular section have we stored our jeans. And so we need to do that because, basically we will retrieve these items as soon as we need them. right? And using that analogy in terms of the processes, that's also the same with random access memory. So we need to store the data in random access memory because we will use them later, as you know, as I am going to show to you later, uh, by showing you one example. Now, on this particular screen, as you can see, I have highlighted the data 10 from the first number and also 10 from the second number and 20 from the data from the variable sum. Now, actually, I have highlighted that to indicate that these data are numbers, right? And so that will bring us to the conversation about or the topic about data type. Now, we need to be able to identify what type of data we are storing in our random access memory so that our random access memory will prepare itself what kind of data it should store. Now, in a nutshell, a variable is a memory space inside your RAM. So you can think of RAM as a building, and a building has a lot of rooms. So RAM is a comparable to a building with lots and lots of rooms, and each room is a variable, right? And that variable will expect what particular data should it accept. So if we say that this particular room, or in this particular room, we declared it to accept numbers, then that particular room or that particular variable should never accept a word. And so when we say that we ask the end user to enter a number, then the expected data that our program should be receiving is a number and not a word. And if in any case the end user will enter a word, which is not the expected type of data that your program is accepting, then an error will happen, right? So in terms of the data type, it is like a question as to whether is it a word, is it a number, or is it a character? And so I need you to focus on this particular table, which shows to you the different data types. So when we expect to receive or when we ask whole numbers from the end user, then the data type in computer programming, not only in Java but also in most programming languages, is int. Int is short for an integer, and integers are whole numbers. So that means they have no decimal points. So if you expect for the end user to enter a data that has no decimal points and are whole numbers, then the data type is int. And below it as an example of variable declaration. So when we declare a variable, we first label it with the data type, and in this case, int, and then the variable name. Now, variable names, or in other books, they are called identifiers, are essentially the names that we give to that particular space in our random access memory. Now remember, we have used building as an analogy to refer to a random access memory. So again, we only use it as a conceptual basis to, to explain this discussion easily for beginners, uh, uh, for the beginners out there. So right. So when we use the analogy of building, so let's say there's a building, and the building is comparable to our random access memory, and a building has a lot of rooms, right? And inside the rooms, those are our variables. And in reality, we name our room. So we could name a room like laboratory A, and then we proceed to another room and we name it laboratory B. We then proceed to another room, we name it laboratory C, laboratory D, or room A, room B, room C, room D, or room 1, room 2, room 3, room 4, room 5. Those names are used to label which particular room are we storing this particular data. And so we have what we call variable names, or identifiers in other references or in other books. So int is the data type, value is the variable name uh, we label for a particular variable within our RAM. And so we've used an equal sign and then 20. So basically, this example is already variable declaration and initialization. So we have declared. So it's like saying, it's like commanding your random access memory to reserve a particular room within its memory because you will be using it, and you are calling that room quote unquote value as shown on this example, int value, and then you are telling your random access memory to store number 20 in that room, and that's initialization. Okay, so this is variable declaration and initialization. Int value equals 2. Now, if you are expecting to receive a data that has decimal points, then that's double or float, right? So as you can see on the example, we say double price 15. In reality, that will become 15.0. That is default because double or float data types are the data types for numbers that have decimal points. Now, if you expect to receive words, then you use string. So we say string, name, and then double quotations, and then the data you wish to store. So let's say Mark. Sometimes you will use a character or a single letter, a single number, a single character, such as a semicolon. And the data type for that is car. And we say, let's say, for example, on this scenario, so we say car, L name, which is short for last name, and then we use P. Now, as you can see, the difference between string and character is that strings are um, enclosed with double quotes, and car data types are enclosed with single quotes. Now, as you can see on this example, this is the syntax of Java, and as you can see, uh, this is our file name, right? So we say public class sample, and then basically, because we're already finished with flowcharts, this part here are considered start or begin in our flowchart, and this part here, uh, they are considered the end or the ending part of our flowchart. And this entire code here are our main code. And basically, when you run a software, your computer will always first look for the main, this one here, the main part of the software. So whatever is inside here is the main content of the program. And so that will run. Now, as you can see on this example here, I have named three variables, int number one, int number two, and then sum. So int number one, we have initialized it to get the value 10. Int number two, we have initialized it to get the value 15. And the third variable here, it was not initialized because the value of sum will depend on the result of this formula, which is n1. I mean, that's n1 and n2 are supposed to be number one and number two. Please check the error again. N1 and N2 are supposed to be number one and number two. You should follow the proper names of the variable. So whatever is the result of N1 and N2 here, or number one and number two here, obviously the result is going to be 25 because that's 10 plus 15. Then it's going to be passed on to variable sum. So sum now internally actually holds number 25. Now, we are displaying it here. System.out.println is used to display something, right? So we double quote what we want to display first. The sum of the numbers is, we end it with another quote, and then the plus symbol here is used to concatenate. That means we will integrate, we will merge these words and whatever is the value of sum. So the value of sum is 25. So the output would become, the sum of numbers is 25. And that's basically the meaning of this example. Now, if you check these, another example, I have just shown the different, uh, a modified way of declaring the variable. Now, since number one, number two, and sum are all integers, then we can declare them all in a single line. As you can see here, number one, we have initialized it to get value 10, comma. Number two, we have initialized it to get value 15, another comma, and then sum. Again, sum is not initialized. We have not assigned any value to it because its value will depend on this formula. Again, may I repeat, N1 and N2 here must not be called N1 and N2, rather number one and number two, because what we declared are number one and number two, not N1 and N2. So these are just mistakes. Please correct it. So the value here is another 25, and so this is still the sum. The sum of numbers is sum or 25, because actually sum contains the value of 25. And that is our example. Activity, please do your personal research and research about how to properly name a variable. There are do's and don'ts in naming your variable. As you can see on this example here, double item price, this is wrong because the variable names should have no spaces in between. So as you can see, item space price, these is incorrect. To correct this one, you you remove the space, and so item price will become sort of one word, or you use a special character here, underscore. This is acceptable. So either of the two, item price and item underscore price, they are all acceptable. And that's basically the fundamental discussions about data types and variables. If you like this video, please subscribe to my channel, and you may also share this to your friends who are learning the basics about computer programming. Thank you, and I hope you learned something today. Bye-bye.